Hey, welcome back to Survival Analysis. And today, before I get back to the lecture note, first I want to show you that SAS is coming. So please make sure you have SAS install. And I just asked Mosaic install one copy. And the SAS, once you install, is very simple. 3 window. One is a data log, one is output, one is editor. So I'm going to just write something simple. Data, fun, OBS, observation, and then input X. Okay, input physics. Physic X, physic Y, and physic Z. And then psychophysics is psych, Z, Y, psycho Z, psycho ZZ, okay? And then we just say that, okay, data lines. I usually just use cars or data lines. And let me just create an Excel file. Okay, so I just run the number. And this equal to 3 times x1 plus 2 times y plus 4 minus plus 4 times C. Okay, and then all we have is a bunch of number. And then I just put it in. Proc print. Run. Okay, show hands. How many of you ever seen this kind of code before? Input, huh? Seen it before? Seen it before? Never? Okay, if you've never seen it before, I would suggest you at least play this one first. What I did is very simple. Reading in some number, randomly generated, and we will probably go back to our Excel exercise some of the problem. So then we'll do live test, slide regression, and then get that done. But all I need right now is, what's the best way to learn a package? Just play with it, right? And what I'm asking you to play with it right now, input. If you don't like to have this many terms, okay, let me just comment it out. You put a star in front of it, you comment this out, and then I just do another one, call input. But this time, I'm not going to input this. I'm going to call it X, Y, Z, psych. Okay? And then if I run it, okay, I have X, Y, Z, and psych. And if you don't want to call it that, you call it physics, like this. You run it, you get physics, X physics, Y physics, Z, and psych. Okay, so your jobs I don't want to collect any homework here because we're using SAS as more like, as a tool for us to do all the stuff we're doing in Excel with more detail. And so we're going to introduce 3 procedures, and we follow the procedure and get the output. There's no intention for me to, I think Dr. Tao Holmes in the energy concentration group, they actually push students to get SAS certificate. So they will take a lot of SAS stuff. But for me, I'm using this more like a tool. And what is this tool doing right now is just input data, output data, okay? You name it any way you like, but just copy 4 column, print 4 column, end of the story, okay? And the only things I will argue is that you can, every time you have a statement procedure, it's called proc. After the proc procedure, have a run statement. And once you have the run statement, see the little guy here, and just say, hey, run this whole thing. It will run for you, okay? Yeah. So install SAS, and depends on your experience and your computer speed. Some is, a few hours job. Some takes forever. So, but you need to learn how to install SAS yourself. Yep.
I'm sorry, I've just never used this before, so I don't even know how to get to that portion of SAS right now, but like where you typed it.
Oh, okay. So go to, you have 2 ways you can get SAS. One is get it from the SAS.com. The other one is using the school. They have a software distribution because it's freeware. You can download that. And once you install everything, okay, and if you type SAS, you will see a size 9.4. And let me close everything. Do it one more time. Because and I'm not going to say, well, yeah, don't say, okay. And so go to SAS. Click on it. You will have the whole things. And there are 3 windows: output window, log window, and editor window. Where, of course, we're going to edit first, so we're in the edit window. And in the edit window, okay, I want to make this really simple. So I just said that, hey, I have a data set. And this data set name is Victory. Okay? You can name any name. And in the Victory, right now, SAS allow you for large data set to import from Excel, CSV, all the other, but for this class, since our focus is on survival analysis, not on SQL manipulation, so usually the data set we just input. And I'll probably just copy paste from Excel. Okay? Input is, it inputs something for me. And we just space it out, call X, Y, Z, and then I have a psych. Is the psychophysics due to X, Y, Z. Okay? And you also notice whenever I have this statement at the end, I have a semicolon. And for your SAS code, since I don't want to get frustrated, once we start getting into the SAS portion, I'll give you the code first. So you have something you can copy, paste, and play with. And then I would start saying that, okay, this is the data set for this problem. Now, let's expand a little bit. That way, you will get used to it. But right now, this is not, I consider anything to do with survival analysis. It's kind of like get used to the data set. Usually, okay, they call it data line for people are saying after that is your data. And since I'm the old school, I actually learned programming using Fortran. So in the old days, we don't call it data line, we call it cars, because we read the punch card. Okay, but cars and data line, same things. So far, so good? And after that, okay, there are things you can do to make it look nice. You can put a bunch of common from place to, anytime you want it. This is a check for SAS installation or something. Okay, for SAS. And you don't need that statement for anything. Okay, just put it there for fun. Okay, I can put it. And if you don't care about that part, you like cars or data lines? Doesn't matter, huh? You like data lines? Okay, we do data lines. So if you use data line, you don't use cards, same things. And then after that, all you need to do, just go to Excel or wherever you have your data set and just copy 1, 2, 3, 4, Control V, 1, 2, 3, 4, done. And when you finish your data set, okay, put one semicolon. Sometimes I even put several semicolons just to kind of split it. So far, so good? And then after that, you just have one statement, proc print, okay, and run. And if you can have a called proc means. Basically have the basic statistics and run. That'll give you your basic statistics out. Okay? So far, so good? And you run it. Okay. See here? You have your observations, 18, right? And then you should see them, what's their average, standard deviation, what's their minimum, what's their maximum. Okay? And you can double check this just by doing here, average. And, oh, shoot, I didn't save the value, so I probably need to bring it back. Copy. Okay. Average. Mean. And max. Okay, so this homework, you don't have to turn in anything. Is that doable? Install SAS and then find some basics. Okay. We're good? Okay. Yeah, this is probably for anybody not doing it. Please stand by. It's coming. Okay, let's continue our psychophysics. Okay, in psychophysics, I introduced two names, okay? One is probit, right? You already hear probit before? Put that down, okay? Probit means z-score approach. And then logit, okay? You also hear names called logit. Logit is logistic regressions approach. And then there's one more. It's called TOBIT, okay? TOBIT. And TOBIT is the survival transfer functions approach. And sooner or later, we're going to converge all those concepts together. But before I do that, I would like you to get familiar with the names. Okay, let me write it down one more time. It's called logit, probit, and TOBIT. Okay? And yeah, here is a simple explanations, and the application, if you type probit, logit, and TOBIT, and I think this is a good one to use. Okay? Probit, logit, and TOBIT relate to the estimation of relationship involving independent variables that are either non-matrix measure or nominal or ordinal scale and possess a lower or upper limit. So remember measurement. How many different kind of measurement? I asked you guys to remember. I said, oh, everything's there are only 4 different types of measurement. What are the 4 different types? Anybody remember? This could be an interview question, just like what is probit, TOBIT. It could be interview questions. Okay, what are the measurement in the world? 4 different kinds. First one is what? Nominal. Color. Green, blue, name. Okay? It's identifiable, so you know what is what. What's the next level? No, ranking. Ordinal. One higher, lower, and the third level, interval, based on distance. And the last one is percentage. That is the ratio scale, okay? And here I'm saying that whenever I measure something in a nominal or ordinal scale or possess a lower upper limit, and we can turn them into a transfer function approach. So look at here. What we did here in the psychophysics, stimulus intensity, can we use z-score to linearize it? And once we linearize it, we say that, no, I don't feel it. Yes, 100% I feel it. And somewhere in between is that transfer point. Remember we talked about that last time? And now we're using logistic regression doing the same things. And logistic regression basically saying that, okay, I have some physics or some x, and there's a proportion for me to decide, okay, I have something or I don't have something. So did you guys turn in the number from the last exercise here? And when you did that, you found that there are certain B0 and B1, certain intercept and parameter will make this relationship as clear as possible to say, oh, beyond certain point, I'll say, yes, I can hear it, I can see it. Below certain point, I cannot see it, I cannot feel it. Can you guys see that? Okay, so multi-objective, this log, this likelihood function is multiplication of a bunch of yes, no, right? And why this is important? because in the transfer function, we say, oh, this is in the psychophysics. Either I can say I can feel it, and later on in the reliability or in the survival analysis, what have you done is the same things. If you stay at 50%, that's one thing. But usually we're taking a risk and saying that, okay, how late is too late? How much is too much? Isn't that same things like you develop a transfer function and you use that transfer function and say that once beyond certain points, I'm going to do something. How many of you ever play at a star market or use an agent? You did? What kind of stocks do you play with?
It's Fidelity.
Okay, Fidelity, so is probably retirement fund of some sort, 401k. Okay, and can you tell your agent and say that if, okay, certain stocks, okay, the price, say now is bull market, the price is going up, 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 but you know that sooner or later it will reach the top, and then it will start getting down. So you should sell it before it's too late, right? And what can you tell your agent? So what is that point? You said that, when this stock XYZ reach $150 a share, sell it, right? So that $150 is almost like what we're doing here, is when you hit a certain mark, the decision is from 0 to 1. Just like when we did, so this is called logic, okay? Victoria, you get it? And in the psychophysics, when we play with the z-scores, the same things, after you hit the 50% or whatever you consider is the PSE, the point of equilibrium, you said, okay, that's my decision point, okay? And why I'm introducing this to, because this two you still pretty much believe, okay, there is a center point you can rely on. So you can say that, okay, here's my center point. Once is 0.1, I go one direction. One is below 0.1, the other direction. So let's say buy stocks. Stock is, right now, I think stock is drop like crazy, right? And do you think it will hit a rock bottom sometimes? Yeah, but do you think you can control your decisions that well, buy at the lowest point? So what do? You tell your agent, buy after the stocks drop till, say, $55 a share, start buying it, okay? So can you guys see the decision here is all about when you reach some midpoint or certain point, go for 1 or go for 0, okay? And psychophysics usually just talk about stuff like this. But what does this got to do with survival analysis and reliability? Because remember, when we play with all those survival functions, counting when something bad happened, the distribution sometimes is heavy tail, sometimes is shallow tail. So where you hit the I3 mark could be very, very little. So for example, say, you don't have much money and you would like to do what? Hang on to your car as long as possible before the car is totally useless. So you're kind of like just, I don't want to maintain it. I want to hang on to it. But you don't want to hang on until, it become accident prone. So you still want to have a safe car. Okay, but Well, I'll tell you this. When I drove in West Texas, Amarillo all the way down to San Antonio, sometimes in the middle of the night, in the wintertime, I'm not talking about now, I'm talking about in the 80s, that sometimes you don't even see a car for miles. So what's the scary part? Say you miss a gas station, and then you start saying that, okay, where, and this is before GPS, you don't know when is the next gas station. You start saying that, okay, do I have enough to hang out for another 40 miles? And what's the scary part is the next gas station got to be within 40 miles. Because if you keep going and going and there's no gas station, you're in big troubles. And you hang on to a car, you're basically saying that, oh, I would like to use this car for another 6 months until I got a big pay raise. But you have to make sure that car can last that long. So now the question becomes, how long is too long? How late is too late? And when we start doing that, we're not doing Tobit or Probit. We start getting into the logit world. The logit world, we don't care where's the 50%. We start saying that, okay, how about 65, 70, 75, 80? You just keep do a little bit, and said that, well, can I survive? And some of you are in the senior projects right now. You use experimental design, maybe, or regression. Do you think your p-value gonna be, what alpha value you use to judge your p-value? 0.05? Whoa, so if you use 0.01, that's very, very tight, right? Yeah, but if you use 0.01 as the level, your beta is at 0.01, right? I'm gonna play dirty tricks with you. Of course, if your p-value is 0.009, you're good, right? P-value is less than your alpha level. What if my p-value, you set your alpha at 0.1, right? What if my p-value is, SAS give you 1.000001, just a little bit above. Are you gonna reject or are you gonna accept? Because the standard you set at 1%, right? And you think that's not good enough. What if, okay, what you have is 0.00999999. So I'm just a little bit better than your alpha level. By the rule, you cannot reject, you have to reject, right? But do you feel, would you bet your life on it? So this is where the survival analysis reliability coming in is that, okay, when I move my threshold a little higher or a little lower, what do I really, what kind of risk we're talking about here? So in this class, okay, why we kind of interchangeable from the order reliability model back to psychophysics, but because sooner or later we're really toy with this psychology of how risky is too risky, okay? Okay, so before I go any further, I want to double check with each one of you. You all understand how to get z-score linearized for your transfer function, agree? You all learned in the last 2 weeks how to use logistic regression to get a transfer function, agree? And before we talk about psychophysics, we can use either simulations or the histogram to generate different transfer function for some weird distribution, Weibull gamma, agree? Yeah, so in your head, you should have 3 different types of transfer function all the time, so we can abuse it. The 3 different type is called logit, probit, and tobit. Okay, I didn't come up with this. This was defined a long time ago by somebody else. Okay. Now, if you this is beyond the scope of this class, I'm gonna just give you a lip service. We can have transfer function beyond 2 levels. So in the originally, we only have 0 and 1. I can have multiple skip. So 0 to 1, 1 to 2, 2 to 3. And every time my logit and probit is gonna written in this fashion. So you still kind of like writing this multiplication. Oh, if it's 1, plug in 1. If it's 2, plug in 2. And once you have this, same thing, you try to find a set of parameters to make this odds ratio as big as possible. So when I said, oh, the probability getting 1 is because of something, and then you should make those beta jump accordingly, okay? And when you do this, you will generate a so-called multinomial logic model. And our usual model is not multinomial, where you're only dealing with 2 sides of a coin, only binomial, okay? But the math is the same way, just, yeah.
So this one, does it only go up 2 levels, like 3 levels?
No. It go beyond. However, I will ask you this, okay? Have you ever been to Baskin Robbins, the ice cream place? Do you like it? Most kids like it, but most kids, do they really go there, try different sample, or they usually still stick with their vanilla chocolate or cookie dough? Do you try different things? Okay. The reality is people check, okay? Mom and pop ice cream parlor, usually they only have vanilla, 1 or 2 flavor, right? And better quality, usually, your family farm, better cream. But most kids want to go to the Baskin Robbins because they have more choice. So multiple choice seems provide utility. Let people say, oh, that's better. But on the other hand, when you go there, you have, because you say you have more options. But in reality, most of people, when they make decisions, they're very likely go back to their usual habit. So if I like chocolate, I might deviate a little bit here and there, but usually the base is still chocolate, okay? And so to answer your question is this, mathematically, you can have multinomial, but for multinomial human decisions, that's not true. Usually people will end up with, a handful of options. That's as much they can handle. Have you ever heard of Miller's memory limitation, 7 plus minus 2? How many digits you have for your home phone number? 7 digit. Most people, we can memorize or have 7 options. And if you look at military or any hierarchical organizations and look at the number of soldiers or officer under each level of command, it usually is around 7, okay? What it really means is that if it's go beyond that, you have difficulty to remember which is which, what is the reason or the rationale behind your judgment, why you like one better than the other. And people like to have options, but in reality is if you have too many options, your decision actually is the quality of your decision is not necessarily reliable. And another typical example is you go to a fancy restaurant, they ask you for salad. what kind of dressing do you want? Put it in, put it out, and they can end up with 10 or 15 different salad dressing. But most people, they probably know 2 or 3, the most common one. And so options provide utility, make you feel like you're making decision. But the decision quality, or for multiple choice, if you have too many choice, it's not good. Most people cannot differentiate with too many options, okay? And sure, I can even talk about politics. The communism was like this, right? They promised the paradise for everybody, so everybody will have a house, will have a car, will have health care and everything. But what's the drawback besides limit of supply? A lot of times limit of options. They have few colors of shoes, clothes to wear. People don't like it. But on the other hand, if you give them too many options, people have problem to decide the multinomial logic itself, okay? And multinomial logic got something to do with modern neural network. And when they have a neural network, they basically say, I have different component, but sooner or later you will use those components, do a linear combinations, and through a transfer function, basically you take the exponential of those things and take the ratio and say that, do I have enough of something for me to push the decision from 0 to 1? So go back to this basic example here. I want you guys to look at this example intuitively, okay? I have a bunch of x. Increase, increase, increase. I only have one x. I could have x1 and x2. Linear combination. So I can have x1 and x2 combined together, and let's just call it x. So this x could be a summation of a bunch of x. Agree? But this ensemble of a bunch of x, some will be high, some will be low. And then you will use the high, low to decide the overall score and said, if your score is higher, ensemble of x is beyond 5, I'll hire you, right? You guys are looking for jobs, some of you are, interview frequently. They will say, I would like to look at your GPA, I would like to look at your manner, how you answer a question, your reaction time, your organization skill, and how savvy are your computer. You use software in a very relaxed way, or some people say, I took Python, I took R, but then people say, okay, what did you use Python for, R for? I took that class 2 years ago. I totally forgot how to. So they will come up with a bunch of x, and then some linear combination, and said almost like your SAT or your GRE got some combination of score. But sooner or later, this x ensemble will let you decide who you're going to hire or who you're not going to hire. Just like I can have a bunch of score to decide if the ensemble score in certain way, you will eat a mint chocolate ice cream. If the ensemble score lower in certain level, you will abandon cookie dough because it's too sweet or whatever the attribute. So psychophysics basically is saying that I'm making decisions based on looking at the x and using those x combinations to say, I'm going to do this or I'm not going to do this, okay? And that's the beauty of using psychophysics. But before I go any further on this, do you guys think that most of us are reasonable decision maker? Huh? Huh? Oz asked you before? Dr. Tanga asked you before?
No, I was just curious who
Uh-huh.
could be are in the situation, just like people in general?
Uh-huh. Yeah. Yeah. Do you think we're rational? Habit, but do you think that from time to time you do stuff outside and violate your habit? Okay, so this is another Simon. Okay, you guys can keep the name. Okay, his name is Herbert Simon. Okay, he's a Herbert Simon, and yeah, this is the guy. He won a Nobel Prize in economics. I don't know, 70 something, and he's a Carnegie Mellon professor, economics, computer science, and I think political science, cognitive psychology. So he's the mixed kind. So it's kind of system engineering in disguise. He created a term called bounded rationality, or he called it satisficing, satisfy and sacrifice. And what it really means is that we are reasonable to some extent, but then after that, a lot of time we're kind of like, this is good enough. So after you feel like this is good enough, you kind of just give up. Imagine I give you a nasty homework. You have to try and try and try. But sooner or later, there will be a time you say that enough is enough. I'm going to turn it in, right? And, well, DOE for response surface analysis is like that. You know that that's the optimum, but how close to the optimum is good enough? That's the tricks, okay? And what do you think that change people from rational to irrational? Of course, you say emotion, but where's that emotion coming from? Time pressure, that could be one. And, frustration. So fatigue, that could be it. The other one is that we call it crowd psychology. You want to conform to others. So there are famous experiment is like this, okay? They let you feel like you're doing something independently. But if I let you surrounded by a bunch of people, actor, and I ask you, what do you think about the table? Is that a nice table? Is it tilted or not tilted? And you have your own independent judgment based on your own psychophysics. This is not a good car. This is not stable. This is something. But if I let you surrounded by a bunch of actors, they all say, that's a good one. Nice. How likely you think that you have the guts to fight against the crowd? Sometimes you cannot do it, right? And hate to say this, the communism and even some religion, some cult, they do the same things. They let you surrounded by certain people, and once you entrain with that situations, it's very hard for you to make independent judgment based on your own logical material and stuff. And this is part of the reason why I like to talk about survival analysis and reliability with some psychophysics spin. Because if we just using the survival data, okay, this thing's die, and so how late is too late? What is a reasonable lifespan of certain things? If it's purely based on physics, we don't have any game to play. Just have a computer code and said, this is too late. If you don't change it, you don't have to change it anymore. But once we start talking about human judgment, okay, I have Toyota just give me a call and said that, oh, we have a good deal for tire right now. Buy 3, get 1 free. And they basically tried to tell me that, I know your tire's still pretty good, but it's getting, wear and tear, and your inspection is coming, and we'll give you a good deal, okay? How likely the timing and say, I'm really busy, I have no time to do all the other stuff, I will be coerced into the buy decision, not because I have the need. It's just because, yeah, fine, I'll just surrender. Okay? And so Herbert Simon is one person that I think you guys should know. And there's another person also related to this. I would like you guys to know. How many of you ever heard Kahneman? Daniel Kahneman. Okay, let me get his name out for you. K-A. Okay. He won the Nobel Prize 2002, okay, in economics too. And I like to talk about them because he's a pure psychophysics. He's a psychologist. But how many of you think that, you all took economics, right? And in your economic class, you started by assuming what? There are limited resources, but our desire is infinite, and with so much desire to pursue so little resources, so there are competitions and everything. That's the human nature, right? But according to Kahneman, that's not necessarily the case. A lot of time we're making judgment or making decision based on a frame of reference. How you look at things and okay, so it's fun to listen to him. He give a couple. There are a couple YouTube talk. You guys should listen a little bit about this. Why? Because they are behavioral specialists. When we're doing OR, operation research, a lot of time your linear programming, mixed integer programming are hard OR. We need to have a little bit of soft OR because we need to understand human behavior could change from time to time, okay? So based on Herbert Simon and Daniel Kahneman, I want you guys to remember 2 curves. They are in the so-called prospect theory. Okay? In the prospect theory, there are 2 curves you need to remember. Let me show you the first one first. Yeah, still based on Kahneman. Okay, this curve basically says this, okay? If I want to gain some, okay, you have your stock gain more and more and more. That's good news, right? But just like, young lady, do you like chocolate? Okay, so 1 chocolate, you're happy. 2 chocolate, you're happy. 10, 20, 100. But the level of happiness, the utility of the happiness, do you think will taper off? So in other words, is that there is a marginal decay of your utility. So if you look at the value of the gain of the stocks, of something you like, chocolate, whatever, the benefit is getting less and less and less. This is this curve. This is common economics. But in psychology, I found it's the opposite way. If I buy a stocks and then, or I say something, the stocks is increasing the price, or your car value is getting more and more, you're happy, but the level of happiness taper off. Now, if it's the opposite way, the price is dropping. You hate it, right? And then, of course, this is kind of like the torture, right? I torture you. Sooner or later, the sense of that evil, the pain, it's getting, you're numb. So sooner or later, the negativeness also taper off. How the tricks is this. Do you think that the taper off, the marginal decay rate for positive things and negative things in human mind the same or different? Positive things, okay, sooner or later, you give up early. But if I buy a stocks or I buy a car, I spend $20,000, $40,000, and now you tell me it's a lemon. Sometimes you don't want to give up. You will put in even more, and so your house, your car, whatever you invest in, become a money hole. You just keep putting in, and this is the prospect theory about the prospect. Our positive prospect, we're lazy. After we gain enough, we're kind of, time to go. But if it's something bad, we tend to say, how could I just let it go? You won't let it go. Okay? And this is the first things, mathematically or economically, they prove that we're not rational. Yeah?
That's because human behavior is to always strive for more happiness, because the equal portion would really be like -20 on the graph. It's like exactly where 50-50 would be. But since we are at that 0 point, it's just like above equal essentially. So we always strive.
According to him, his argument actually is Kahneman. And Kahneman actually worked with another guy is called Tversky at Stanford for a while. And Tversky got cancer, died young. So even when Kahneman got the Nobel Prize, he acknowledged, he said that I shouldn't get this credit by myself. I have a partner, but he died young. But when they did all the experiment at the time, they basically said is that we have a frame of reference. So when I make the decision, say that I'm taking it now, that time I will have a frame and say that this is a good value. And so if it increasing, I'm always go back to my original value and say, compare with my origin. Am I gaining more? And we tend to kind of like gain 10 chocolate or 15 chocolate. I'm saying no more chocolate. Maybe not for her. but on the negative stuff, we're kind of like, no. I put in so much, I'm not going to let go. And that's the first thing about prospect theory. I want you guys to understand in the psychophysics, there's something related. And I will have one more curve to show you. And if you can explain this using your own language, when you talk about in a job interview, it's important. I know you guys probably got brainwashed by me more than once. Talk about optimization, talk about statistics. But at the same time, you also need to understand that using statistics, using optimization to explain human behavior, there is a limit. And how to explain those limits is important.
Okay, so the prospect theory graph, like just the drop off and like the rotate, like is that like how people get like, I guess does that relate to like almost like gambling?
Yeah, it's called, he has a name called endowment effect.
Okay.
How I endow. And I want to add one more curve to prospect theory. Okay? In prospect theory, they also talk about probability. Okay? And I would here we go. I would like you to also remember this curve. Okay? The previous curve, can you remember, kind of memorize it? You can visualize it, right? Because that will be helpful for you to explain it. And this is the second curve about prospect theory. Okay? hey, they won a Nobel Prize. So, it's no harm to remember these two curves. In this curve, it basically said that, in a decision about probability, okay, now we're talking about psychophysics of the probability. When something is very, very low probability, okay, so this is from 0 to 1, it's 45-degree line. We tend to overestimate. We tend to overestimate low probability. So a lot of time, why you buy stocks? I think last month there was $1 billion lottery. How likely you think that we're going to get it? But guess how much people convinced me to spend? I think I spent $40 or $80 on that one. Why I did it? Well, I was more like, fine, you guys want to do it, I'll chip in. But at the same time, the rational mind of me, knowing that we overestimate the low probability. And then we tend to underestimate the sure things. Okay? How many of you think that in a thunderstorm or very, very bad weather, slippery road conditions, the probability of having an accident is pretty high? But how many people will say that, no, I just drive very slow, I'll be careful, we'll be fine. And so, insurance company a lot of times love to evaluate people's tendency of how they're doing things in critical conditions, because we have the gap of underestimating high probability. And the crossing point, some people say the crossing point equal to this value, okay? It's exponential 1. And no, it's not exponential 1. It's 1 over exponential 1. So the crossing point, some people say is somewhere around 27%. Below 27%, we tend to overestimate. After 27%, we tend to underestimate. Okay? And Victoria, I know I kind of like sidetracked to explain what's multinomial. But the reason is that there is kind of like a fuzzy in between logit, probit, and tobit, okay? Or relate to the same things. We need to estimate the reliability, the survival analysis based on the data. But if I show you the same data, I show everybody the same data, do you think we would make the same decision? Here, I give you a car statistic saying that how long this car can last, or a mechanics can be reliable. Okay, so we all have the same number and same reliable probability function. Do you think we will make the decisions on when to change the car, when to do something based on the same threshold? What will be the a factor changing your mind and my mind? Previous experience. So if you had a bad accident because of bad car, you probably will be careful more. How many of you also believe that it got something to do with economics?
Like socioeconomic, like class.
And I will tell you this. I've been to, you guys know I worked for an insurance company before. I got invited to visit a country, okay? And in United States, the number one workers' compensation cause is low back pain. Everybody say, oh, my back hurts, I cannot work. And I'll get, 75% pay, 80% pay workers' compensation. And in this country I visit, okay, people need to carry sacks of rice, climb up from a boat dock, cross a 6-lane highway, busy street, to load those rice into a train car. Okay, so what was the number one deaths or casualty over there for those people? Hit by the traffics. So the researcher I know, he actually investigate some of those body, and when he checked their spinal disc, it's all dry because of years and years of torture of carrying heavy load. Do you think that those people have back pain? But since they don't have workers' compensation and they have to get paid in order to get food, bring food to their family, so they will keep risking their life and just ignore whatever we consider is very, very painful. So I'm trying to tell you, what he told me at the time is that, Simon, remember, decision-making is not purely based on the biology, the physiology, the physics. It's also based on human decision a lot of time. It is based on the survival. What is high priority, what is low priority of something? We all experienced COVID in the last 3 years, right? How many people you think that even though they know they could get infected, but they still go to work every day and interact with people? They're taking risk. So I think we're going to stop early today, but I want you to remember the following few things. Okay? Can you read Google Wikipedia? Who is this guy, Herbert Simon? Because he is a very important decision scientist about how to make decisions. And the other guy is Daniel Kahneman, okay? And his thesis about prospect theory is important. Daniel Kahneman. And finally, read prospect theory, okay? Of course, the most important people involved, I probably say Herbert Simon and Daniel Kahneman, but there are a lot of other people contribute to prospect theory, like Tversky, okay? And if you want to talk about prospect theory, okay, about when we make decision, probability is not real probability. It's the psychophysics of the probability. You need to remember two curves. What are the two curves? The first curve is this guy, the chocolate curve. Something positive, taper off very quickly. Something ugly, you just don't want to give up. You want to keep it until, I used to use this to explain what is a bad marriage. Some people stay in bad marriage for a long time. Why? They just feel like, I cannot give up, I cannot give up. I want to keep, putting more. And I know that's, but it's a good visualization about this curve. Something good, after a while you say, I have enough, I want to give up. But something bad, you just don't want to give up, don't want to give up. And the other one is about the probability itself. Human judgment on probability, we overestimate low probability, underestimate high probability, okay? And my anecdote is I do have students out interview for jobs, and people will say that, oh, you show me you know Python, you know R, you can do data mining, but how much do you know about human decisions? And this is the soft side of the human decision, but it's the critical side. Okay, I'm going to let you go now. See you next time.